Another learning day, math enthusiast. Your teacher Marlene prepared lots of examples on our topic about addition or subtraction of radicals. Remember, in adding or subtracting radical, add or subtract the coefficients of similar radicals. But what are similar radicals? These are radicals with the same radicand and index. By the way, similar radicals is sometimes called like radicals. So these two words are pertaining to the same meaning. Now some examples of like radicals are cube root of 2, 3 cube root of 2, and 10 cube root of 2. Can you see the similarity among the radicals? Yes, the presence of cube root of 2. On the other hand, do not add or subtract radicals if they are dissimilar or unlike radicals. They are unlike or dissimilar if they have different radicand, index, or both radicand and index. Now look at these examples. We have cube root of 2, cube root of 5, fifth root of 2, and square root of 10. Cube root of 2 and cube root of 5, although they are both cube root but have different radicand, such as 2 and 5. While the cube root of 2 and the fifth root of 2 have both 2 as radicand but of different indices, such as 3 and 5. And square root of 10 do not have the similarity at all. Now let me show you how to add or subtract radicals using the following examples. For example 1, our given is 3 square root of 2 plus 4 square root of 2 minus square root of 2. Observe that the square root of 2 is common, so we're going to collect the coefficients. So, we have 3 plus 4 minus 1. So, times the common radical, which is square root of 2. So, 3 plus 4 is 7, minus 1 equals 6. So, 6 square root of 2 is our answer. Have you observed the pattern of combining radicals? Now let us solve number 2. Our given is 4 square root of x plus 6 square root of x minus 9 square root of x. Have you observed the common radical? Yes, and that is the square root of x. So we can collect all the coefficients, such as 4, 6, and negative 9. So combining 4 plus 6, we have 10. Minus 9 is 1. Then times the square root of x. That is equal to the square root of x. So coefficient 1 is invisible and not to be written. So this is our final answer. Let us continue with example number 3. Our given is the square root of 24 minus the square root of 54 plus the square root of 96. Are they similar? At first glance, obviously, they are unlike or dissimilar radicals. But let us try to simplify them. So we have to factor the radicand. The square root of 24 is factored as the square root of 4 times the square root of 6. The square root of 54 is the same as the square root of 9 times the square root of 6. And the square root of 96 is equal to the square root of 16 times the square root of 6. Let us simplify the perfect square into The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. Now, have you observed the similar radicals? Yes, since the square root of 6 is common to all of them. So let us collect the coefficients. So 2 minus 3 plus 4 times the square root of 6. So 2 minus 3 is negative 1 plus 4 is 3. Therefore, we have 3 times the square root of 6 is the final answer. Now let us move to number 4, where our given is 3 times the square root of 50 minus 3 times the square root of 48 plus 2 times the square root of 12. Now think of the factors of the radical. For square root of 50, we have the square root of 25 times the square root of 2. The square root of 48 is the square root of 16 times the square root of 3. And the square root of 12 is the same as the square root of 4 times the square root of 3. Then let us simplify the perfect square. So, the square root of 25 is 5. The square root of 16 is 4. And the square root of 4 is 2. Then multiplying the coefficients, we have 3 times 5 is 15. Then copy square root of 2. Negative 3 times 4 is negative 12. Copy the square root of 3. And 2 times 2 is 4. And copy the square root of 3. Now, have you observed similar radicals? Yes, it is between negative 12 square root of 3 and 4 square root of 3. For 15, square root of 2 is dissimilar to the other two. So we can only combine the coefficients of the square root of 3, which are negative 12 plus 4. And that is equivalent to negative 8. So we have 15 times the square root of 2 minus 8 the square root of 3. This is the final answer. Let us have more examples. Our example number 5 given is x, the square root of 2y, minus the square root of 32x squared y, minus 2 over y, times the square root of 8x squared y cubed. Let us separate the perfect to not perfect square. So we have to copy x, the square root of 2y, since that is already in simplest form. Then, we have to factor the square root of 32x squared y into the square root of 16x squared times the square root of 2y. While the last term, negative 2 over y, times the square root of 8x squared y cubed is separated into negative 2 over y times the square root of 4x squared y squared times the square root of 2y. Then let us simplify the perfect square. We have the square root of 16x squared is 4x. And the square root of 4x squared y squared is 2xy. Then copy the remaining parts. Then, we can cancel y over y, which is equal to 1. Then, negative 2 times 2x is negative 4x. Now, since the square root of 2y is now common to each of them, we have collected the coefficients into x minus 4x minus 4x. So, the quantity is the same as negative 7x. Then copy the common radical, which is the square root of 2y. And this is our final answer. Now let me show you another case. For number 6, our given is the cube root of 81 minus 2 times the cube root of 128 plus the cube root of 250. The indices are the same but radicands are different. Let us express them into exponential form. So the cube root of 81 is the same as cube root of 3 raised to 4. The cube root of 128 is the same as the cube root of 2 raised to 7. And the cube root of 250 is factored into cube root of 5 cubed times 2. Then let us simplify by isolating the perfect cube root. So the cube root of 3 raised to 4 is the same as cube root of 3 cubed times cube root of 3. Then negative 2 times the cube root of 2 raised to 7 is equal to negative 2 times the cube root of 2 raised to 6 times the cube root of 2. Then finally, the cube root of 5 cubed times 2 into the cube root of 5 cubed times the cube root of 2. Simplifying the perfect cube root, we will get cube root of 3 cubed is 3. Cube root of 2 raised to 6 is 2 squared. And cube root of 5 cubed is 5. Now looking at the resulting radicals, we have the cube root of 3 and the cube root of 2. We can only combine the coefficients of cube root of 2 and separate 3 cube root of 3 because it is dissimilar to the other two. Then from the coefficients of cube root of 2, we have negative 8 plus 5 is negative 3. Therefore, we have 3 times the cube root of 3 minus 3 times the cube root of 2. And this is our final answer. Now let us see how rationalizing denominator can be applied to our next example. For number 7, the given is the square root of 1/3 plus the square root of 1/6 plus the square root of 1/2. So let us separate the radical into fractions, then rationalize. So the square root of 1/3 is the same as the square root of 1 over the square root of 3. And to rationalize, multiply this to square root of 3 over the square root of 3. So we will get the square root of 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is the square root of 3 squared. Wherein we all know that the square root of 3 squared is 3. Let us proceed to the square root of 1/6. So to rationalize, multiply this to square root of 6 over the square root of 6. So square root of 1 times the square root of 6 is the square root of 6. And the square root of 6 times the square root of 6 is the square root of 6 squared. And the square root of 6 squared is 6. To simplify the square root of 1/2, multiply this to the square root of 2 over the square root of 2. So that we will get the square root of 1 times the square root of 2 is the square root of 2. Then the denominator, the square root of 2 times the square root of 2 is the square root of 2 squared. And the square root of 2 squared is 2. Now, after simplifying, observe that the radicals, they are all dissimilar. And since we cannot combine them, we will consider this as our final answer. For a deeper understanding of the topic in simplifying and combining radicals, let us see number 8. Our given is 8 times the square root of 3/8 plus 1/4 times the square root of 48 plus 4 times the square root of 96 minus 4 times the square root of 3/4. Looks complicated? Don't worry. Let us start by simplifying each term. For 8 times the square root of 3/8, let us factor the denominator, the square root of 8, into the square root of 4, or 2 squared, times the square root of 2. So getting the square root of 2 squared, which is 2, then we can cancel 8 and 2 in the denominator so that we have 4. Then looking at the denominator, we have square root of 2. So to eliminate this, let us multiply to the square root of 2 over the square root of 2, so that we have 4 times the square root of 3 times the square root of 2 is 4 times the square root of 6, and the denominator, the square root of 2 times the square root of 2, is simply 2. So cancel 4 by 2, so the result is 2 square root of 6. Now let us proceed to the next term, which is 1/4 the square root of 48. So we can factor this into 1/4 times the square root of 16 times the square root of 3, where the square root of 16 is 4. So cancel 4 by 4, which is 1, times 1 is also 1. Then times the square root of 3 is the square root of 3. And let us copy square root of 3 to align in the first term. Now look at the third term, 4 times the square root of 96. Separating the perfect and not perfect root, we have the square root of 16 times 6. That is for the square root of 96. The square root of 16 is 4, then times 4 is 16. Then copy square root of 6. Again, let us copy to align in the first and second terms. For the last term, which is 4 times the square root of 3/4, by separating the numerator and denominator, we can easily observe that the square root of 4 is equal to 2. Then divide negative 4 by 2, which is negative 2. So we have negative 2 times the square root of 3. Let us copy to the first 3 terms. Then radicals are now in the simplified form. Let us combine similar terms. 2 square root of 6 with 16 square root of 6. So combining the coefficients, we have 2 plus 16, which is 18, times the common radical, which is the square root of 6. Then the square root of 3 with negative 2 square root of 3. So combining the coefficients, 1 minus 2, which is negative 1, times the common radical, which is the square root of 3. So we have 18 times the square root of 6 minus the square root of 3 is the final answer. Well, if you observe some complicated given, try to simplify them one by one before combining them together. Well, I hope you learned from my discussion. Try to practice the task given to you by your teacher. If you want to clarify from your task, do not hesitate to write your comment. I will surely answer you in the most possible time. So again, before I end, since I discussed about addition and subtraction of radicals, let me share this food for thought. For a happier living, add joys to the world, and subtract evils in our heart. God bless everyone.